StephenMStigler, The 7 Pillars of Statistical Wisdom. Embrace the fascinating world of statistics as we explore the essence of The 7 Pillars of Statistical Wisdom by StephenMStigler. This book navigates the historical and modern relevance of 7 fundamental structures that shape data science and analytics. From debating the value of the summary over raw data to understanding the importance of context, the book showcases the multidisciplinary nature of statistical science. Prepare to journey through vital themes like the significance of study design, the influence of Francis Galton's work, and the evolution of statistical methods in response to 21st century challenges.
The 7 Pillars of Statistics. Over time, the concept and application of statistics have undergone significant changes, with an increasing number of scientific principles influencing it. The book, The 7 Pillars of Statistics, provides an overview of the fundamental structures supporting data science and analytics. The 7 columns, or pillars, provide insight into modern applications while standing on ancient ground. Despite being a discipline of data study, its reach extends beyond just physical and social sciences and is sparking debates in economics, biology, and big data fields. Overall, statistics remains a central discipline vital to the field of data science and analytics. The controversy of data analysis. The first column of statistics, the combination of observations, has sparked substantial debate in the data analysis world. It involves calculating the mean, which involves discarding some information to generate a comprehensive and accurate conclusion. Some argue that this is a valuable way to gain insights, while opponents stress the importance of external factors and detailed narratives about current events. Economist William Stanley Jevons urged market watchers to use a price index figure calculated from the average percentage of price changes in commodities, but others argued against it. A short story by Jorge Luis Borges supports Jevons' theories of the importance of basic and broader price moves. Without the mean calculation, data yield perfect recall without comprehension or synthesis. In summary, the controversy revolves around deciding what information to prioritize and whether the mean calculation is the best way to do so. The root n rule. The ancient Greeks debated how much information is enough to determine the effectiveness of health therapy, leading to the emergence of a mathematical solution known as the root n rule. This formula, based on the square root of the total number of data sets, helps in selecting a sample size of information. The rule implies that a second set of data is far less valuable than the first, making the process useful in various fields from stargazing to economics and medicine. The second column of statistics aims to measure the value of subsequent sets of information and develop processes for gathering data. Context matters. The absence of context in discussing numbers is detrimental as it provides a framework for standardization and comparison. A framework ensures that data-driven measures date back hundreds of years, and statistics employs the yardstick of probability to measure differences. Standardizing the third column provides a vehicle for probability measures and comparison. Prestigious medical and science journals fall into the trap of using numbers devoid of context, as exemplified by a headline discussing celiac disease, which fails to reveal the time frame and number of children dying yearly. Galton's statistical breakthroughs. Francis Galton, a cousin of Charles Darwin, introduced the correlation and regression to the mean method in 1885. His work showed significant variations could exist within a set of data, allowing for the explanation of deviation. Galton's regression method estimated the level of variation that emerges in the same set of data and explained diversity within a family, which is why members of the same family can have varying, inherited physical traits. His breakthroughs in statistics also linked to explaining the basic flaws in Darwin's theories about evolution and natural selection. The power of study design. The design of a research study or trial can greatly impact the resulting data and outcomes. Elements of study design include size, queries, time frame, conditions and treatments, randomization, and quality control. The Bible's Book of Daniel serves as an early example of a clinical trial, while farming, drug treatments, and even lottery selections have been subject to study design. Randomization is a useful tool for eliminating bias in experiments. The design of a study is crucial for producing reliable and valid results that can be used to further scientific knowledge. Mastering residual analysis. Residual analysis, an approach of evaluating and comparing scientific concepts, involves examining factors that existing theories do not address. In his book, A Preliminary Discourse on the Study of Natural Philosophy, John Herschel outlines its characteristics, which include simultaneous factors that can complicate data and lead to conflicting information. Researchers must follow several steps, including outlining the procedures and models that created the database, examining the data divergence from expectations based on that model, and crunching the data through two different models. This approach will help experts gain a better understanding of any puzzle or case that existing theories fail to solve. The future of statistical analysis. Statistical analysis has undergone significant changes, especially with the advent of big data. Traditional models have become inadequate, as they lack flexibility in handling complex problems. Researchers must explore new methods for analyzing data and develop additional pillars to supplement the existing 7. The future of statistical analysis requires an approach that can handle extensive and multifaceted problems. Statistical analysis must evolve and adapt to ensure successful and accurate prediction of forecasts based on big data.
As we wrap up this journey through the 7 pillars of statistical wisdom, it is evident that statistics, as a discipline, has evolved over time in response to different fields and real-world applications. The book encourages us to appreciate the significance of summary, context, experimental design, regression, and residual analysis in making sense of complex data. Moreover, it emphasizes the need for updating and expanding statistical models amidst the era of big data. While the existing pillars provide a solid foundation in the field of statistics, we must remain open to potential new pillars and advancements in order to stay ahead of the analytical landscape.